All right, in today's lesson, we're going to be looking at the solubility rules. You guys were introduced to these on either Thursday or Friday of last week. They should be in your notes, but if they're not, I put the solubility rules that we're following right at the top of the worksheet. On this worksheet, we're going to be doing three things. We're going to predict the products of double replacement reactions. When we do this, we need to make sure that the charge of every compound always balances out to zero. The second thing we're going to do is use the solubility rules to decide if each compound is either aqueous or solid. Then, when we're done with that, we want to make sure that the equation is fully balanced, meaning that we're starting and ending with the same amount of reactants as we do products. So, right now, we're going to go down to number 1, calcium bromide and sodium phosphate combine to form what two products? So the first thing I want to do is look at my periodic table. You can either bring one up on your iPad or you should have a hard copy of this. On the periodic table, we need to find the elements that are listed in problem 1. The first element is calcium. Now calcium is in the second column, and that tells us that calcium is going to have a positive 2 charge. So I'm going to list here that calcium is positive 2. Calcium is with bromine. Again, looking at the periodic table, we can find bromine in the 7th column, or 17, and this one we know will always have a negative 1 charge because they're 1 away from the noble gases or 1 away from getting a full octet. Now, in our other compound, sodium phosphate, again, we'll find sodium. Sodium is in the first column on the periodic table, so that would be positive 1. And phosphate is an example of a polyatomic ion. That would be on your polyatomic ions list. Just to save time, I'll tell you phosphate has a charge of negative 3. So the reason why we have to find these charges is so that when we switch our two positive ions, or the two cations, that the two compounds that form are going to be neutral. So my two cations would be calcium and sodium, since those are listed first and have positive charges. So if I swap these, I'm going to end up with a compound that contains sodium and bromine. To figure out the correct ratio of sodium to bromine, I need to look at the charges, so positive 1 and negative 1. Those balance out, so we don't need any subscripts. The other product that forms would be calcium. Again, remember its charge is positive 2, and phosphate, which has a charge of negative 3. So on this one, positive 2 and negative 3 don't balance out, but we know positive 2 and negative 3, our least common multiple would be 6. So I'm going to have 3 calciums and 2 phosphate groups, because 2 times negative 3 equals negative 6, and positive 2 times 3 equals positive 6. So those two would come to 0. Remember that when you have a polyatomic ion, if there's more than one of them, we have to put parentheses around the outside so that it doesn't look like there's 42 oxygens. So we've just achieved part A, predicting the products. The second part, decide if each compound is aqueous or solid. I have to refer to the solubility rules. So here I can see sodium bromide. There's a rule that says compounds containing bromine are soluble. There's also a rule that says compound containing group 1 elements are going to be soluble. So because sodium is in group 1 on the periodic table, that would mean it's soluble. So I'm just going to write AQ after sodium bromide. Calcium phosphate, if we refer back to our rules, I actually can't find any rules that say anything about phosphate or calcium. So if it's not on our rules of solubility, we'll assume that it is insoluble, therefore forming a precipitate or a solid. So we've now achieved part B of the reaction. Last thing is to balance the equation. So here you might want to rewrite the full equation so that there's space for it. I have calcium bromide and sodium phosphate going to sodium bromide and calcium phosphate. The problem here is that calcium on this side, I have only 1. On the product side, I have 3. So to fix that, I'm going to put a 3 in front of calcium bromide. By doing that, I just multiplied the bromine also by 3. So on the reactant side, I have 3 times 2, which would be 6. So over here, I need to put a 6 in front of sodium bromide. Now that makes it so that there's 6 sodium, so we would multiply 3 sodium by 2 to make it so that there's 6 sodium on the reactant side. The phosphate, we already had 2 of on the product side, so that is balanced out. So now we've achieved all 3 parts that we needed to do. We predicted products, we determined if each thing is aqueous or solid, and we balanced the equation using coefficients. So now we'll move on to question 2. If you'd like, at this point, you can pause the video to attempt this problem on your own. However, if you feel like you need another example problem, just follow along with the video. So we're going to do the same thing. We're going to assign charges to each part of the compound. You find magnesium on the periodic table. Magnesium is under column 2, right? Magnesium has a charge of positive 2. Hydroxide, OH, is an example of a polyatomic ion. So again, you would find this on your polyatomic ions list, but this has a charge of -1. Aluminum on the periodic table is in column 13. So column 13 has a charge of +3. And sulfate, another polyatomic ion, you would find it on the polyatomic ions list, has a charge of -2. So now we take the 2 cations, they swap places. We're going to end up with a compound that contains aluminum and hydroxide. Aluminum has a charge of +3, hydroxide -1. So to balance these out, I would have to have 3 hydroxide groups, right? 3 times -1 gets us to -3 plus +3 would result as a 0 charge. Our other product is going to be made up of magnesium, charge of +2, and sulfate, charge of -2. So here where we have +2 and -2, those balance out, and you don't need to add in any extra coefficients. So back to our solubility rules to do part B, I need to find any rules about aluminum or hydroxide. Hydroxide compounds, it says, of group 1 and 2 are soluble. However, hydroxide compounds of transition metals and aluminum are insoluble. So that would tell us that this is a solid product. Magnesium and sulfate, I can see here there's a rule about sulfate that says they are soluble. So that would be aqueous. Now the only part I have left is balancing the equation. So to balance, I need to make sure that I have the same number of reactants as products. Again, I'm just going to rewrite the whole equation so that there's plenty of space here to put in coefficients. So at this point, I need to look and see, are there the same number of magnesium on both sides, Right now it looks like there are. However, the hydroxide, on this side I have 2, on this side I have 3. So I need to use 6 as my common multiple and have there be 6 on each side, which would mean I put a 2 in front of aluminum hydroxide and a 3 in front of magnesium hydroxide. So now that makes it so that there's 3 magnesiums on this side. So I need to put 3 magnesiums on this side. Now my sulfate matches out because on this side there were 3 and the aluminum is already balanced. So that's our balanced equation. Again, if you feel like you've had enough of an example here, you can pause the video and try to complete number 3 on your own. But if you want another example, just go through the process with me. So on the next one, we have a transition metal, copper. Remember, you can only figure out the charge of the transition metal based on what it's with. So nitrate has a charge of -1, but there's 2 nitrate groups. So in order for this compound to have a charge of 0, it would mean that copper has a charge of +2, right? -1 times 2 equals -2 plus +2 would get us to 0. Over here, ammonium, NH4, is another polyatomic ion with a charge of +1, and it's with another polyatomic ion, hydroxide, which has a charge of -1. So again, we're switching the placement of copper and ammonium, and I'm going to end up with ammonium with nitrate. Here, our +1 and -1 charges balance, so we don't need any subscripts. The other product that forms would be made up of copper and hydroxide. But copper still has its +2 charge, hydroxide has a -1 charge, so now I need to make sure the charge balances out, so I'm going to make it so that there are 2 hydroxide groups. 2 times -1 plus +2 would get us to 0. Next part is the solubility of each of these compounds. So if I look at my list of rules here, there's a rule about ammonium that says compounds containing ammonium are soluble. So that would make our first product aqueous and our second product, copper hydroxide. Remember, we used this rule in the last problem that hydroxide compounds, if they have transition metals, are insoluble. So that would be solid. Now I need to again make sure that I have the same number of reactants as products. Copper, on this side I have 1, on this side I also have 1. The nitrate, however, I have 2 nitrate groups because that's outside of the parentheses. So I would have to double the nitrate groups by putting a 2 here. That now doubles the amount of ammonium, 2 ammonium groups. So in here, I'm just going to insert that I would put a 2 as the coefficient since I don't have enough space. But there would be 2 ammoniums, also doubling the number of hydroxide groups. And over here that works because we have 2 hydroxide groups. So that one was fairly simple to balance. Now we'll move on to number 4. So I would challenge you at this point to try to pause the video and see if you can go through the problem on your own. Obviously, after trying it on your own, please watch the video to see that you either did it correctly or need to fix your mistakes. So we'll now go through this problem. Magnesium, based on where it is on the periodic table, has a charge of +2. Chlorine is listed here under column 17, and this has a charge of -1. Sodium is in the first column on the periodic table, so it would be +1. And carbonate is a polyatomic ion with a charge of -2. So we're going to swap sodium and magnesium. Those are the two things that are cations. And we're going to form magnesium carbonate. Magnesium being +2, carbonate being -2, so we don't need to add in any subscripts. Plus our other product, which would be sodium combined with chlorine. Sodium is +1, chlorine is -1. So again, we don't need any subscripts there. Now I'm going to look at the list of solubility rules to determine which of these, if either, is a solid. So looking at the list of rules, I don't see anything about carbonate. So with there being no rules about carbonate or magnesium being soluble, I would say that this is our solid. Sodium and chlorine, however, we have a rule about chlorine saying that they're soluble. We also have a rule about group 1 elements, and sodium was found in group 1. So that would be aqueous. Now to go through and balance this, again, we need to find something that's not the same on both sides. So here, sodium, on this side I have 2, on this side I only have 1. So I'm going to put a 2 here. That doubles the sodium, it also doubles the chlorine, which works because on this side I had 2 chlorines. So just to double check that magnesium and carbonate are also balanced, on this side I had 1 magnesium, on this side there's 1, and on this side I had 1 carbonate group, and on this side I have 1 carbonate group. So we're now done with number 4. Number 5, again, I'm just going to go through and quickly find the charges. So calcium is in the second column, so it would have a charge of +2. Hydroxide is a polyatomic ion with a charge of -1. Lithium is in the first column on the periodic table, so its charge is +1. And carbonate is a polyatomic ion, which would have a charge of -2. Sorry, I actually have a typo on here. I will fix this before I post the worksheet, but on my particular copy, I've written the formula wrong, so this should actually be Li2CO3, so that the charge of the compound is 0. Again, that will already be corrected on your worksheet, but on mine there's an error here. So now I need to predict the new products, so I'm going to switch the placement of calcium and lithium. I'm going to end up with a new product that's made up of lithium and hydroxide, lithium being +1, hydroxide being -1, so we don't need any extra subscripts, plus now calcium and carbonate. So calcium is +2, carbonate is -2, and again, we don't need any subscripts because those charges have already balanced out. Now, based on our solubility rules, I can see there's a rule about group 1 elements. I also see there's a rule about hydroxide compounds with group 1 elements, saying that they are soluble. So this would be aqueous and calcium carbonate. There's no rules here about carbonate, so we're going to assume that our compound containing carbonate forms a solid. Then I just have to go through and make sure that this is balanced. On this side, I would have 2 lithium. On this side, there's only 1. So I'm going to put a 2 in front of lithium hydroxide. That balances out the number of hydroxide. Then I just have to check calcium. I have 1. Over here I have 1. And then the hydroxide, I have 2. Right here I have 2. So now we've checked and made sure that everything is balanced. So on to our last one. Again, pause the video and try this on your own and then watch the solution. So potassium, based on where it is on the periodic table, would have a charge of +1. Hydroxide would be -1. That's our polyatomic ion. Here, lead is an example of a transition metal, so we have to figure out its charge based on what it's with, nitrate. Nitrate has a -1 charge, but if we have 2 nitrate groups, that would be a charge of -2. If there's only one lead, the one lead would have to be +2. So now we're going to swap the places of potassium and lead, and I would end up with potassium with nitrate. Potassium is +1, nitrate is -1, so I don't need to add in any subscripts. And I'm going to have the other compound be lead, remember charge +2, with hydroxide. Hydroxide has a charge of -1, so we would have to have 2 hydroxide groups to make it so that the overall charge is neutral. Then I'm going to look at my solubility rules. I have a rule about nitrate, right? Nitrate are soluble, so this would be aqueous. And then lead hydroxide, we're using the same rule we used last time. Hydroxide compounds with transition metals are insoluble. So this one would be our solid. Now I just have to make sure that it's balanced. So you can see there's 1 potassium, 2 nitrate groups. So I actually have to put a 2 in front of potassium nitrate. That doubles the amount of potassium. So over here, again, I would put that in front, but I don't have quite enough room, so I'm just going to insert a 2 here. That doubles the amount of hydroxide, and over here I have 2 hydroxides. Lead, I only have 1. Here I have 1, so everything is balanced. If you have questions about this, again, remember, feel free to email me, but also feel free to pause the video, go back to any spots where you're not totally sure of what to do. And then make sure that when you're done with this, that you either take a picture of it if you were doing it by hand, or if you were doing it on the iPad, save the version and submit it on Google Classroom so that I can give you credit for doing this work. Thank you. Hope you're having a good day.